Lesson comes from Go Math lesson 13.5, and where we're choosing appropriate measures of center and variability. Now, before we go on, let's just talk a little bit about what we mean by measures of center and then what we mean by measures of variability. Well, you can think of measures of center as things that are typical. So, what might be typical in a set of data? Well, if we were to find the mode in a set of data, I'm going to just change this to red really quickly, because measures of center are what is typical or what is most of the data kind of like. So the mode would definitely tell us what's typical because it gives us the most frequent value. The mean would also kind of tell us what's typical generally because it gives us the average. And then the median is what's telling us kind of like what's smack dab in that middle. On the other hand, measures of variability really talk about how that data is different or varied or how it can be spread out. So variability, we just want to denote as what is different about that data, or how is that data different, and how is it varied by meaning of spread. So we're looking at range, we're looking at interquartile range, and we're also looking at mean absolute deviation. It says underneath the essential question of how you can choose appropriate measures of center and variability to best describe a data set that outliers, so remember what an outlier is, right? Gaps, clusters often can affect measures of center and variability. Some measures of center and variability may describe a particular set of data better than others. Okay, so that's good, important information to keep in mind. Now, as the Unlock the Problem reads, Thomas is writing an article for the school newsletter about a paper airplane competition. In the distance category, Kara's airplane flew 17 feet, 16 feet, 18 feet, and 15 feet, as well as 2 feet. Should Thomas use the mean, median, or mode to best describe Kara's results? Explain your thinking. Well, let's first of all underline what this question is asking us to do, and we're asked to determine whether Thomas should use the mean, median, or mode to best describe Kara's results. I'm just going to box around mean, median, mode. There are math signal words there that kind of tell us what we're going to have to do in the operation. We also have some important number facts: 17 feet, 16 feet, 18 feet, 15 feet, and 2 feet. And that's the data values that we're working with. Now, over off to the box here, that's just a really important question. That question asks us, do we need to order the numbers? Well, what do you think? We're asked to find mean, median, and the mode. Well, the mean, we don't need to. The median, do we need to? Yes. The mode, we don't. But yes, simply because we are finding the median. Now, we don't need to do that right away because we are going to right here find the mode first, the mean first. And so let's just list the data values as they have them here: 17, 16, 18, 15, and 2. And let's add those all together. And you should have a calculator with you because, again, we're really focusing on our computation, not on our computation rather, but our statistical analysis skills. And we don't need to really get tripped up by any computation errors. So we've got 68 as the total of these values. And what do we have to do when we now find the mean after we've added them together? Divide by the number of observations. So that's 68 divided by 5. And it's not going to be a whole number. That mean is 13.6 feet is our unit of measure. Now we have to find the median because here's our mean of Kara's data. Now for the median, we definitely want to order the number values from least to greatest. And that smallest number value in this set is 2. And then comes the 15. And then comes the 16. Then comes 17 and 18. Well, let's go ahead and look. 1, 2, 3, 4, 5. There's definitely a middle value. 2 and 2. 16 is our median. Now, are there any repeated numbers here? 17, 16, 18, 15, 2? No. So there is no mode. The mean, let's take a look at it. Well, is it greater than or less than the median? it's less than 4 of the 5 values, actually. If I look at it, it's less than the median, but also if I look at 13.6, 1, 2, 3, 4 values are greater than this mean here. So it probably is not a good description of the measure of center. Now, why would I say that? Think about what's kind of typical in this data set: 17, 16, 18, 15. I would think 16 is more like what's typical. So it's not a good description of the center, but this median happens to be kind of near where most of the data values are. Look, just one away, just one away, just two away. Unlike the 13.6 here, we can say it's 14. Still, it's not as typical of what the data results should be. So Thomas should, in fact, use the median in this case to describe Kara's result. Now, the explain I'll let you do on your own time. I'm going to go ahead and have us look at the second set of problems here, so the video is not so long. All right, so now let's look at the example on the next page. If you want to, you can pause it, take a second to read it to yourself so that you can get kind of like a close read in for the second time that I read through. Mr. Tobin is buying a book online. He compares prices of the book at several different sites. While the table shows his results, we're going to make a box plot of the data. And in addition, we're going to use the plot to find the range and the interquartile range. And we're asked which measure best describes the data. We've got to explain our reasoning. So today, again, a lot of our focus is choosing this appropriate measure of center and variability given a scenario. Should we use the mean, median, or mode, or should we use the range or interquartile range? Now, we need to obviously also make a box plot. So we want to underline what the question's asking us. We don't have any key facts other than this table really here. And then we need to just maybe emphasize that we have to explain our reasoning or highlight that. Okay, so now we're going to make a box plot. Here's the prices of the sites, the books at the various sites, and the values that we're looking at, first of all, are here in this column. If I wanted to highlight it, I could. But let's go ahead and see. We've got to order the data from least to greatest. Well, what's the smallest number value? 5. What's the next smallest number value there? 15. What's the next value there? 16. What's next? There's 17 and a second 17. And then we've got 18. And then we've got 35. Well, let me count. 1, 2, 3, 4, 5, 6, 7. Perfect. There's definitely a center. 3, 3. Our center is spot at 17. Now, our first quartile is going to be everything to the left of 17. And here we go. 15 is our Q1. And then our Q3, we can think about it as the middle of the upper half. That's exactly what it is. And let's just put $ since we're working with money. And now we need to make a box plot. Well, our 5 num sum in our box plot happens to be our minimum value of 5. Let me just go ahead and make sure I put min, and I'm going to put 5. Now, our next one is our Q1, our first quartile, which would be 15. Let me do my line. Our median is 17. This box plot's going to be pretty tight. Our Q3 is 18. It's right in the middle of the 17 and 19. And our highest number value is all the way at 35. Now, what are some of the things you notice right away? Well, I notice this box is very box-like. It's not a long rectangle, but look. Whoa, look how spread out here and here are. Seems to be an interesting dynamic happening with this max and this I'm sorry, this minimum value and this maximum value. And let me just go ahead and put max value at 35. And they already have the label or title for us in it. Well, now let's find the IQR. Well, IQR is looking at 35, the max. I'm sorry. Let's find the range first. The range is looking at the maximum value, which happens to be 35, and then looking at the minimum value, which happens to be 5, and subtracting the 2, that gives us 30. Then we've got interquartile range, which is just looking at the distance of 18 and, or difference of 18 and 15, which happens to be 3. Now, when we look at these, how many of the 7 prices are actually within the interquartile range? So let's go back to our data. Now, if I look between 15 and 18, let's go back to my table. 15 and 18. How many data values are between 15 and 18? Let's highlight them. Well, between 15 and 18, you are. 1, 2, 3, 4, 5 between 15 and 18. Well, I think that since 5 of those data values out of just the 7 data values are within the IQR, that probably is a pretty good indicator of what this data value, how different it is, or what's kind of the better measure of variability to use. So 5 of the 7 prices are within the interquartile range. The other 2 prices are much higher, much lower, and that's why we see this max and min. So I think it would be safe to say the interquartile range would definitely describe that data better than the range would, because the range, I mean, it's a pretty broad range of 30. But really, 5 of those 7 data values are within there. Now, one of the things that I want you to think about is describing a data set for which the range is a better description than the interquartile range. You're going to want to talk to a partner about that in a moment before we get started. And let's look at the hot problem, the last piece. How can you tell from the box plot how varied the data is? Well, in this case, this box plot, look at it. Look at the shape. That shape shows us that, it's very short here, very tiny. The box is very small. So that tells us the interquartile range is there. It's going to be less variation there. But if we notice these long lines to the max and the min, that lets us know, wow, there probably was an outlier. And in this case, there were 2 kind of, because 5 is well below the 15, 16, 17, 18 range where we have our interquartile range. And then 35 is well above. So you can go ahead and annotate those pieces, and hopefully you'll have no problem solving the rest of the lesson.